So you can use a parabolic reflector to focus sound, light, or radio waves to a single point. And those of you that were in Physical Science 20 with me, you know all about parabolas and the focus point, right? That's what they're talking about. So you can see a little bit of this picture here. This seems to be a guy at maybe a football game. It's outdoors in the summer. Looks to be some pretty large guys around him, so I'm assuming this is a football game he's at. But this green sort of parabolic dish, I don't know if you can see that very well on the board, but this green dish is in the shape of a parabola. And he is focusing that on the action. And in the center here, or the focus, I should say, this is a microphone. All right? And so all of the sound waves from the field come in, and when they hit this parabolic dish, wherever they hit on the surface, they are reflected to the microphone. Wherever they come and hit, they're reflected to the microphone, whichever spot they hit. So in this way, this microphone, instead of just getting a few rays of sound coming directly from a source, it gets all of these rays of sound. You see, all of these sound waves from a large volume really of space. That's the basis behind that. Okay, and you guys should know that from science class. Okay, so it explains what it is here. Rene, a journalist, is using a parabolic microphone as he covers the Francophone Summer Festival of Vancouver. Okay, maybe that's him, maybe it isn't. Describe the region that Rene can cover with his microphone if the reflector has a width of 50 centimeters and a maximum depth of 15. Okay. Now, it's going to be difficult for us to think about a parabola opening up sideways like this. That's not what we're used to, is it? This is not a function. So even though parabolic dishes are held sideways, okay, like this, we have to think about this as a parabola, but it has to either open up or down. Okay, that's how we have to arrange it. So you can't just draw this on a coordinate plane and expect everything to be the same. Okay, we could switch around the x and y variable, but I don't really want to go there. So let's just make sure that this is up or down. Okay, and I don't think it really matters which one you do. So let's make a little bit of a sketch. It's always a good idea to make a little bit of a sketch. And so what you would do on this one is you would say, okay, here's my coordinate plane. Let's just make the vertex in at center here, 0, 0. And let's see, describe the region. So this is going to be the region. The solution region is going to be sort of inside the parabola, right? That's what we're looking for. So let's sketch out this parabola. It has a width of 50 centimeters. So here's my parabola. And this total width is 50. So we've got, really, this is negative 25 as a point here. And this is positive 25 because that's a width of 50 in total. And it has a maximum depth of 15. So it looks like if we say this point right here is the maximum depth here of this parabola. This would be 15. Apologize for how small that is, but I just want to leave some space for myself to work. But okay, this is sort of what it would look like, right? A parabola and 25, 25, 15. Yeah?
Wouldn't the vertex on the y value be 15? That's the maximum depth.
Well, okay, so wouldn't the vertex be 15 up here? Okay, so you could draw this a number of different ways. You could draw the parabola like this if you wanted to. Yeah, you could. It would be a slightly different function, right? But it would still be a good description of the area. What I'm doing is I'm setting the parabola kind of upside down, laying it on the floor here, and this is 0, 0. Okay? So yes, you could turn the parabola upside down and set it on the floor, which is the x-axis, and then you could have the vertex at 15 totally. Yeah. You're going to have a different inequality if you do it that way than I'm going to have here, but that's okay. Yeah. Either would be acceptable. Yeah. Because remember, we're describing points that are kind of encompassed by this parabola. Okay? So whether it's faced up or down doesn't really matter. Probably a better idea to face it up in a sense because this parabola, I mean, it doesn't really matter. It's a good question, but I'm going to do it just the way that I've started it. But that could work as well if you decide to do it that way. Okay? All right. So what do we know here? Well, we have to come up with the equation for the parabola, don't we? So we have to come up with the equation for the parabola. So y, equals, I guess, something. Now we could use the vertex graphing form. I guess we could start that way, right? We have a vertex of 0, 0 here. So if we do a times x minus 0 squared plus 0, I just have y equals ax squared, right? And I'm going to have to find out what my a is. And that's easy to do because all I have to do is pick a single point that I know is on the parabola now. That's not the vertex. And I could find out what a is. So I know that I have a point up here, and maybe this isn't real clearly drawn, but I have a point here that is 25 and 15. So 25, 15 is a point that I know that's on the parabola, given the information. So guess what? I put in 15 for y and 25 for x. And I solve for a, and that's going to complete my equation of this parabola. So that's going to be 15 over 625 equals a, and which also, that reduces down to 3 over 125. Okay, that's my a value. So I now have, and again, if this is sketchy for you, okay, come talk to me or let me know, or I have videos on this as well, like, parabolas, and you remember that, I could direct you there. But coming up with the equations here is something that you will need to do. You have learned that in the past. You'll still need to know how to do that. So y equals 3 over 125 x squared. So that's the equation of this parabola. Now, do you think we should have this an or equal to? Like, am I going to include the points on this parabola, do you think, or not? What do you think and why? Anybody have any answers to that? Should I make this an or equal to? Okay. Okay, you said no because it's a border, you can't catch sound waves in the material. Okay. If sound waves originate from in the material, that's not what we're after, so that's a good argument. Does anybody have a counter argument or agree with that?
I think
Having equal to would define the border better. Okay. Okay. Anybody? We've got one for each side. Anybody else have an argument there that want to tip the scales here? These are both good arguments. I guess what I would say is that the sound that bounces off the parabola also makes the parabolic dish vibrate, which those vibrations would be collected by the microphone too. So I think you would be technically okay to do either. But if you think about, your own voice, right? Your vocal cords are not only causing a disturbance in the air that allows you guys to hear me, but it's also vibrating my whole head, right? And so I'm able to hear the sound waves that are coming through my my jaw and my skull and everything like that. I'm able to process that vibration as well. And that's why your voice sounds so different when you hear a recording of it versus what you think you sound like when you talk, because you're getting lots of more information from inside the vibration of your actual head and body. So so I would be okay with either. I think probably a little bit better argument would be for the or equal to. So we will include this as a solid line. But I like both arguments. So now what we need to do is we need to express this inequality as either a less than or equal to or greater than or equal to. And I'm just going to use a test point. I'm not going to use 0, 0 because it's on the parabola. But you could use something like 0, 1. You could use 0, 1. That's an easy one. So let's do 0, 1. Well, 0 compares how to 3 over 25, 125 times 1 squared. 0. The other way around. The 1 is over here. My bad. So 0 is x, and 1 is over here. X is 0. So 1 is what compared to 0? This is 0. 1 is greater than, right? So guess what? This should be a greater than or equal to sign. And all the points that are in here, this is the sound region that this parabola will collect. All of those points satisfy this inequality. Okay? So the region covered by the microphone can be described by this inequality. Okay, this inequality, and where really x is from negative 25 to positive 25. So really it doesn't catch any sound waves that come out here, right? Doesn't catch those. So it only catches the ones that come from here to here. So the domain, remember we did restrictions on domain the last couple chapters and stuff like that? That would be also helpful information to mention here. So x is between negative 25 and positive 25 for the domain. Oops. Okay. So that would be also part of a good answer. Any questions there? All right.